If the body is undergoing a movement or if the body is in motion in a plane, it is nothing but the body is having two-dimensional motion. So any physical quantity is having only a magnitude, we call it as scalar, and the example for scalar is length, mass, time, temperature, and etc. What is the meaning of parallel vector? Vectors which are having their lines of action parallel to each other. Hello everyone, welcome to session 1 of chapter 4, Motion in a Plane. This is Swati, Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear students, we have already studied a chapter called Motion in a Straight Line, where we have studied the motion of an object in one dimension. So this is a chapter where we are going to study the motion of an object two-dimensionally. The chapter itself says motion in a plane, which means the motion in two dimension. As if the body is undergoing a movement or if the body is in motion in a plane, it is nothing but the body is having two-dimensional motion. The best example to understand the meaning motion in a plane is projectile motion and circular motion. So in this chapter called motion in a plane, we are going to understand so many laws and theories of a particle which is moving two-dimensionally. So to understand this, we must have a knowledge about scalars and vectors. What is the scalar and a vector? Why we have to study this? Yes, if a body is undergoing a motion in a straight line, there are only two directions possible, either forward direction or backward direction. So this direction is indicated in motion in a straight line by the symbols called plus and minus. Either the body is moving in a direction which is positive or it is moving in a direction negative. But if the body is having two-dimensional or three-dimensional motion, that is motion in a plane or motion in a free space, we must know about vectors. Because in one-dimensional motion, the symbols which are used to say the direction of a particle, whether it is moving forward or backward or whether it is having a positive direction or negative direction, a body is having two-dimensional or three-dimensional motion, vectors are the representation. So let us know what is scalar and what is vector. So any physical quantity that has only a magnitude is called a scalar. What do you mean by magnitude? Magnitude is nothing but a quantity, just a number. So any physical quantity is having only a magnitude, we call it as scalar, and the example for scalar is length, mass, time, temperature, and etc. The vector is nothing but the quantity which is having both magnitude as well as direction. So any quantity which is having only magnitude is scalar. Any quantity which is having both magnitude and direction is called as vector. So scalar, just a magnitude, and the example mass, length, time, temperature, etc. But vector means a quantity which has both magnitude and direction. Example, we can say weight, force, acceleration, and etc. So these are the quantities which have both magnitude and direction. Sometimes we'll say, for example, force, it is a vector quantity. Mass, it is a scalar quantity, which means what? So to define all these quantities, whether it is a scalar or a vector, we must understand what is the meaning, how to define these two quantities. So I think it is clear now to everybody, a quantity which has only magnitude is scalar, magnitude plus direction is vector. Let us now look into the differences between these two quantities, that is scalar and vector. As I already told you, scalar has only the magnitude. But vector, it has direction and magnitude, and it changes with change in magnitude. Scalar will change by changing its magnitude, but in case of vector, it changes with change in magnitude as well as direction. Example for scalar, speed, distance and time, velocity, acceleration and force are some of the examples of vector. So knowing about these two differences are very important. Next, now we got to know what is a vector. Let us now see how to represent this vector. What is the representation? So here, look at this picture. So here, if I write a length, if I write a line segment, the length of this line segment is representing the magnitude. If this line segment has got with an arrow mark, it represents the direction. So now look at this example. Here AB is a length of the line segment. So in this length of the line segment, A is the initial point. A is the initial point and B is called the end point. It is also called as the tail and tip. So the initial point is named as tail and the final point or the end point is called as tip. As I told, the length of the line segment AB represents magnitude and the arrow mark at the end represents the direction. So the representation of vector is through this symbol. So it means the length of the line segment says magnitude, arrow mark gives us a direction. So any physical quantity has magnitude and direction is called as vector quantity. This is how we have to represent vector. Now we came to know the definition of vector, the representation of vector. Let us now look into the types of vector. What are its various types? So the first one is zero vector or null vector. Null means we know nothing, zero. So let us now define it. A vector whose magnitude is zero. Magnitude means quantity. So a vector whose magnitude itself is zero is called as null vector or zero vector. For example, a dot, we call it as a zero vector. A point is a null vector. Next we have unit vector. What is the meaning of unit vector? Vector whose magnitude is equal to 1. So 1 is unity. So the vector whose magnitude is 1 is called as unit vector. So the unit vector in the direction of A, look at this, unit vector in the direction of A is denoted as A cap. Unit vector is denoted as A cap. This is vector A, but unit vector is denoted as A cap. So unit vector whose magnitude is equal to 1. Any vector whose magnitude is equal to 1 is called as unit vector. We can also write this as modulus of vector A into A cap, which is equal to A vector. Or from this we can write A cap is equal to, A cap is a unit vector, vector A divided by modulus of vector A, where modulus of A is not equal to 0. If it is equal to 0, then we will call it as a null vector. So it is the condition, the modulus of A should not be equal to 0. The magnitude of a vector is also called as modulus of the vector and it is denoted by this one, modulus of vector A. So knowing to represent the vectors is also very important. All these representation have different meanings. So it is important to know about each and every representation of writing vectors. I hope it is clear now. Any vector whose magnitude is 0, null vector, vector whose magnitude is equal to 1. Next, let us denote this unit vectors in a 3-coordinate system. So along x-axis, y-axis and z-axis. So the unit vectors along x-axis, y-axis and z-axis is given by I cap, j cap and k cap respectively. Next type of vector is equal vectors. Most of the scientific terms defines by their names themselves. What is the meaning of equal vectors? Two vectors, let us say vector A and vector B are called as equal vectors and it is written as vector A is equal to vector B if and only if both of the vectors have same magnitude and both are traveling in the same direction. We all know vectors means it should have both magnitude and vectors. Let us say vector A and vector B, for example, when they are said to be equal, when both of these vectors have same magnitude and they are traveling in a same direction. So if these two conditions satisfies, we can say that these two vectors are equal vectors. What is negative of a vector? So we'll say, we know what is equal vector. Now let us say what is negative of a vector. A vector which is equal in magnitude but opposite in direction. If magnitudes are equal and direction is also same, we'll call it as equal vectors. If magnitude is equal, that is the length of line segment is equal and the direction is opposite, then we can say it is negative of a vector. Let us see the another type, that is concurrent vector. What is concurrent vector? Vector whose initial points or origins coincides. So let us now see this example. This is the initial point. As I explained in the first slide, initial point is the starting point. So this is the initial point of B and this is initial point of A. So the initial point of these two and also this vector, they coincides. The origin coincides and these type of vectors are called as concurrent vectors. So our next type of vector is coplanar vector. What is a coplanar vector? So two vectors that lie in the same plane. They share the plane. So when the two vectors are sharing the same plane or they lie on the same plane, we'll call it as coplanar vector. Next type of vector is a parallel vector. What is the meaning of parallel vector? Vectors which are having their lines of action parallel to each other. So any two vectors, their lines of actions are parallel to each other, which means the tip or the initial point of them will never coincide. The end of them will never coincide. So these type of vectors are called as parallel vectors. Here you can observe these are anti-parallel vectors because they are not moving in the same direction. So parallel vectors, they move in the same direction, which means their lines of actions are parallel to each other. They are acting in this direction and these lines are parallel to each other and hence the name parallel vectors. So far we have seen what is a vector, what is the representation of a vector and what are the types of vectors. Now let us learn about the operation of vectors. So why do we have to know about the operation? So any two vectors of same kind which is having the same units can be added, subtracted, but by following certain laws. So how to add two vectors, how to subtract two vectors. So learning these operation on vectors plays an important role in solving critical physical laws or in solving the critical physical derivations. So to solve all these things in a simple way, the mathematical simplification must be required and vector languages helps us in solving these difficulties. So it is important to learn about operation of vectors. So let us see now vector addition, how to add two vectors. So two vectors of the same nature means they are representing the same physical quantity in the same unit and they can be added. How can they be added? They can be added using the following rules. So what are those following rules? The first rule is triangle law of vector addition. Very important question, examination point of view as well. Triangular law of vector addition. So here, what is the statement of this triangular law? How can we add two vectors with the help of a triangle law? Let us see that. So statement states that if two vectors can be represented in the magnitude and direction by two sides of a triangle taken in the same order, then the resultant vector is represented by the diagonal or the third side of the triangle taken in the opposite order. It is so simple. Statement may look lengthier, but it is so simple. Any two vectors, they can be represented in magnitude and direction by two sides of a triangle taken in the same order. Look at the diagram now. This is one vector, vector A, and this is the another vector, vector B. So they are represented by magnitude and direction taken in the same order, like this. They are in the same order. Then their resultant is represented by the third side of a triangle taken in the opposite order. This is the third side of a triangle which is taken in the opposite order. The resultant is represented, which means the hypotenuse of a triangle is representing the resultant of addition of these two vectors. So let us now get the simplification. So let us now learn this in detail. So let two vectors A and B be represented both in magnitude and direction by the sides of AB and BC of a triangle ABC taken in the same order. So let us say this is a triangle ABC. Let two vectors, vector A and vector B, says the magnitude and direction by the sides AB and BC respectively of a triangle ABC. Then the resultant R, which is equal to addition of vector A plus vector B, represented by the third side of a triangle which is taken in the opposite order. I think by the diagram it is very simple to understand the statement and the explanation of triangular law of vector addition. So writing the diagram and the terms explanation is very important in understanding triangular law of vector addition. So I repeat, triangular law of vector addition once again. Look at the diagram. Here two vectors I have taken, vector A and vector B, represented both in magnitude and direction, taken in the same order in a triangle. Then their resultant vector is represented by the third side of the triangle, which is taken in the opposite order. So simple to understand and very important examination point of view. So this is one law. What is the another law? That is parallelogram law of vector addition. So parallelogram law of vector addition states that if two vectors can be represented both in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, then the resultant vector is represented by the diagonal of the parallelogram passing through that point. So to understand the statement, look at the diagram so carefully. Here vector A and vector B, they are represented by both in magnitude and direction. So two sides of a parallelogram represents vector A and vector B by the magnitude as well as direction. Then the resultant is represented by the diagonal of a parallelogram taken from that point. Is a statement of parallelogram law of vector addition. In triangular law of vector addition, we have taken two sides of a triangle represented by magnitude and direction are the two vectors. Then the resultant is taken in the opposite order, that is the sum of vector A and vector B. But in case of parallelogram law of vector addition, now here two sides of a parallelogram representing vector A and vector B, which is taken in the same point, the resultant is also represented from the same point, but it is represented by the diagonal of a parallelogram. I hope the statement is so clear to everybody. Let us move. Let us study this in detail. So let two vectors, vector A and B, represented both in magnitude and direction by the adjacent sides OA, OA and OB respectively. Then the resultant of these two, that is denoted by capital A, which is equal to vector A plus vector B, is represented by the diagonal of the parallelogram, which is nothing but OC drawn from the same point. What is this resultant then? Resultant is nothing but the result which is getting from both these vectors. This resultant gives the net value of the individual vectors and they brought together what is the actual task they can do. So the total net value is given by the resultant value. So now how to find this resultant? What is the expression? Let us now see. The resultant of a number of vector is that single vector which produces the same effect as the net effect of all the individual vectors acting together. It is so simple to understand. The resultant is nothing but the result. So what is this result? If many vectors which acts together, there will be a formation of some effect. So the resultant vector will also give as the same effect of all these vectors which acts together. So the net effect of all the various vectors which acts together will be equivalent to resultant vector. That is what our statement is also saying. The resultant of number of vectors is that a single vector which produces the same effect as the net effect of all the individual vectors. So what is the expression for magnitude and direction of resultant vectors? How to find the magnitude and direction of the resultant of concurrent vector? We came to know what is concurrent vector. How to find the resultant of this concurrent vector? By using the expressions for magnitude and direction, we can easily find what exactly is the magnitude and the direction. And the expressions are R is equal to root of A square plus B square plus 2ab cos theta, or it can also be written as r is equal to root of p square plus q square plus 2pq cos theta. It is nothing but the representation. What are the variables we use to represent the vectors? Based on that, we can go with the formulae. So, r is equal to root of a square plus b square plus 2ab cos theta is the expression to find the magnitude of resultant vector of a concurrent vectors. Now, how to find the direction? The formula to find the direction of resultant vector is theta is equal to tan inverse of b sin theta divided by a plus b cos theta. So, these two are the very important factors to know in the study of vectors. So, dear children, this session is about the introductory part of scalars and vectors. What are the significance? What are its types? What is the representation of vector? Why we have to study vectors? In the upcoming session, let us know about more things in detail. Until then, take care all of you. Thank you.